Probability and compound events. Let's first start with simple probability. Simple probability is when you have the number of favorable events, the things you want to have happen, over the number of total events. An example would be if you were rolling a die and you wanted to know the probability of getting a prime number. So this stands for probability, and the probability of whatever we have in the parentheses. So I want the probability of finding a prime number if I roll a die. And if I roll a die, the outcomes are 1, 2, 3, 4, 5, 6. And the prime numbers are 2, 3, and 5. 1 is not a prime number. A prime number has two factors. So for 2, that's 1 times 2, 3 is 1 times 3, and 5 is 1 times 5. So we have 3 favorable outcomes out of a total of 6, or 1/2. So the chances of getting a prime number is 1/2. Compound events are different. They're not just one thing happening, they're multiple. Compound means multiple things. So there's more than one thing happening. So for example, let's say we want to flip 2 coins and find the probability of getting matching sides, like heads and heads or tails and tails. Now typically with compound events, you're going to want to make a list of all the possible things that can happen. On the first coin that I flip, I can get heads or I can get tails. On the second coin that I flip, let's say I got heads on the first one, and now I'm flipping again, I can get heads or tails again. Let's say on the first one I got tails, I'm flipping again, I get heads or tails on the second one. That means that my list of outcomes could be, I could get heads and heads, heads and tails, tails and heads, or tails and tails. This list of outcomes is called the sample space. The probability of getting matching sides, here's one and here's one, is 2 out of 4, or 1/2. Tree diagrams are a tool to help you make a list of all the outcomes. So let's say we want to roll a die and flip a coin, and we want to find the probability of getting a 3 and getting heads. When you draw your tree diagram, put a starting point and decide which one are you going to do first. I'm going to roll the die first. And the die has 6 outcomes, so I draw 6 branches. 1, 2, 3, 4, 5, 6. And I list all the outcomes. I can get 1, a 2, a 3, a 4, a 5, or a 6. Now I need to flip the coin, and those have 2 possibilities. So on the die I could have gotten a 1, and on the coin I could get a heads or tails. I could roll a 2, then I flip the coin, I could get heads or tails, and then so on. Once you have your tree diagram drawn, you can use it to make a list of all the outcomes. So if I follow the branches, I get a 1 or a head, 1 and tails, 2 and heads, 2 and tails, 3 and heads, 3 and tails, and so on. Remember, this list of outcomes is called the sample space. Now that we have a list of all the things that can happen, we can find the probability of getting a 3 and heads. And you can see that that only happens once out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes. So the chances of rolling a 3 and getting heads is 1 out of 12. The fundamental counting principle is a shortcut to find the total number of outcomes. So if you don't need a list of all the outcomes, you just want to know the total number, then use the fundamental counting principle. Let's think back to the probability of rolling a 3 and getting heads. Let's not find the probability, but let's just find the outcomes, the total number of outcomes. If I roll a die, there's 6 outcomes. If I flip a coin, there are 2 outcomes. If I multiply these two numbers, that tells me that there's a total of 12 outcomes. So to use the fundamental counting principle, multiply the outcomes from the simple events to find the total number of outcomes. When you get a credit card, you choose a 4-digit PIN to use as a password at ATMs. How many possible PINs are there? So let's imagine you got 4 digits, and each of these digits can be the numbers 0 to 9. So that means that you have 10 choices for each digit. To find the total number, you're going to multiply all 4 of these outcomes. So 10 times 10 times 10 is, there's 10,000 pins.